Welcome to this explainer. Okay, today we are laying out the absolute blueprint for mastering system integration in integrative programming and technologies 2, or IPT 102 as you probably know it. If you're ready to graduate from just writing isolated scripts and actually start building modern, interconnected enterprise systems, you're in exactly the right place. We're going to map out the whole journey, taking you from foundational architectural theory straight through to deploying a living, breathing, multi-component application. So, here's our roadmap. We'll start with architecting system integration, move on to the language of HTTP and JSON, then bridge those systems with REST APIs. After that, we'll hit the practical application in IPT 102, and finally, wrap up with achieving the final capstone. All right, part 1, architecting system integration. To hit course learning outcome 1, we really have to ask the big picture question. How do completely heterogeneous applications actually connect? You've got different technologies, totally different programming languages, and different platforms. How on earth do you get a mobile app, a web dashboard, and some legacy database to operate as one seamless entity? This is the core puzzle that IPT 102 aims to solve right out of the gate in week 1. Well, the primary blueprint we use to solve this puzzle is the client-server architecture. Think of it as a setup where independent apps, we call those the clients, request services or resources from centralized providers, the servers. This intentional decoupling, it's exactly what makes modern web systems so incredibly scalable and easy to manage. What's really cool about this approach is how strictly it divides up the responsibilities. On one side, you've got the front-end client. That's the face of the operation, the UI you tap on your phone or click in your browser. On the completely opposite side is the back-end server. That's the heavy lifter crunching the data, locking down security, and talking to the database. Two totally separate worlds that have to perfectly sync up. To make this abstract idea a bit more concrete, think about the real-world examples you'll be dissecting early in the course. Imagine how an app like Gcash integrates with totally separate traditional banking systems, or consider how your university's LMS somehow talks to the student information system to instantly sync your grades. These are massive, complex systems acting like best friends entirely thanks to the client-server model. Moving right along to part 2, the language, HTTP and JSON. So to make this client-server connection actually happen, these systems need a common tongue, right? Enter JSON, or JavaScript Object Notation. In week 2, you're going deep into data formats, and JSON is essentially the universal translator of the web. It's incredibly lightweight, we humans can read it easily, and machines can parse it in a flash. It bridges the gap seamlessly, no matter what programming languages your front and back ends are written in. And here's how that conversation flows in the real world. Step 1. The client kicks things off by firing off an HTTP request using methods like GET or POST. Next, the server catches that request, processes it through an API, and finally packages the requested info and shoots it back as structured JSON data. It's just a constant, standardized back-and-forth conversation. Which brings us to part 3, bridging systems with REST APIs. Now that our systems can speak the same language, we have to build the actual bridges. That's where REST APIs come in. REST stands for Representational State Transfer. Basically, it's a strict set of rules and constraints that lets applications communicate securely using those standard HTTP methods we just talked about. Nailing this down is your main mission in weeks 4 through 6, because it's exactly how developers expose server resources in a way that's totally predictable. Because to hit course learning outcome 2, you're not just duct taping things together, you are engineering them. You're going to master proper resource naming conventions, setting up CRUD endpoints, create, read, update, and delete. You'll learn exactly which HTTP status codes to throw so the client knows what's up, how to handle API versioning, and how to properly document the whole shebang using industry standards like Swagger or OpenAPI. All right, part 4, practical application in IPT 102. So, what are you actually building with? You've got some powerful technology choices here. For the backend API track, you can roll with Node.js and Express, or you can go with PHP 8 and the Laravel framework. Then, to wire up to those, your front-end clients will be built using vanilla JavaScript, or if you're feeling adventurous, you can jump into React. You're getting your hands dirty on both sides of the client-server equation. Because let's be real, learning these tools isn't just about the theory. Your tangible course goal here is to build front-end clients that consume both the APIs you build in class
and external public APIs. This hands-on, practical application is exactly what you need to knock out course learning outcome 1 and truly master mapping data between totally different systems.
And finally, part 5, achieving the final capstone. This is your ultimate destination, and I really want you to remember this magic number, 3. To successfully hit course learning outcome 7 and actually pass your final defense, your deployed system has to be composed of at least 3 communicating components. Let's break down exactly what those components are. Your full-stack project is going to need a front-end client, a back-end REST API wired up to a database like MySQL or Postgre, and here is the kicker, you must include at least one external integration. Maybe that's a third-party payment sandbox, an SMS notification service, or a live mapping API. Weaving all those diverse pieces together in a Dockerized, cloud-deployed environment, that is the absolute proof that you've mastered this architecture. In fact, the syllabus literally calls this project a readiness gateway to the capstone course. So for the focused learners out there, keep this in mind. Completing this full-stack, multi-system integration project isn't just another homework assignment. It is the absolute, mandatory, final prerequisite, proving you are ready to tackle Capstone Project 1. So, as we wrap up this explainer, I've got one big question to leave you with. What integrated system are you going to build? Are we talking about an online enrollment sandbox with a real payment gateway, a clinic app with automated SMS nudges, or maybe a live ride tracker using a Maps API? Start brainstorming how you can use client-server architecture to solve actual, real-world problems. The tools are right there laid out in front of you. Now, it's time to start building.